a new topic, two-dimensional integer array. Two-dimensional means what? It has a number of rows and columns. Two-dimensional array are commonly referred as a matrix. You can also call it as a matrix. If you have a clear idea about single dimensional array, then it is very easy to go forward with dynamic it is very easy to go forward with two-dimensional integer array. If you declare array by using, for example, integer x 3 by 3 array, that is, it consists number of rows because the first index is for row and the second value is for columns. Therefore, then the array is created like this. The first value is located 0 0, the next is 0 1 0 2, 1 0 1 1 1 2, and the last value is 2 2. That is, index is always start from 0 till the number of rows -1 and number of columns -1. If you watch it carefully, you can find that here the first value is 0, second is 0, the first remains 0, the second is 1. Again the first remains as it is and the second is 2. Whenever the row change, then the next row is 1, again column set to 0, 1 1 1 2. Again in next row is incremented and again column set to 0. Therefore, if you want to access all these locations in your program, you can simply use a nested loop of I and j. If I is 0, j is 0, then initially I remains 0 because I is in outer loop, j is in inner loop, and then j get plus plus j1 j2. Then whenever the inner loop get false, the cursor comes in outer loop and then I get incremented, j is again set to 0. Like this, for accessing all these locations, we can simply use a nested loop, nested for loop. Let us see the example. If you want to scan or print element from matrix, then how to scan it? Print and or scan and print. We should have here two header files. Okay, declare first single matrix here. For better understanding, we use matrix of 3 by 3. You need here two index value I and j. If you want to scan values in matrix, then also it will start from 0 till the number of -1 and number of rows -1 and column -1. Therefore, here first give message, ask user to enter 3 by 3, that is total 9 elements. Use here also /n. Then within outer loop there is I. In inner loop initialize to j. And now scan values. We want location from 0 0 0 1 0 2. Therefore, if you watch it carefully, the I is 0, initially j is 0. Initially these values are 0. That is, x of 0 0 means what? First location. Then j plus plus the second location. J plus plus third location. Then whenever j get false, then I get incremented. Therefore, I is 1. J again set to 0. Therefore, 1 0. That is your next row start. Like this, your whole elements are stored in 0 0 till the 2 2 in order. Now print these elements. if you want print all these elements in matrix form, then here use a space and within outer loop write there /n, then output will be in matrix form. Okay, it is a simple printf, or here we simply print the element of matrix. But if you want to print matrix with its location, that is 0 0 0 1 0 2, then you can simply write like this. Here first print the values of I and j and then continue with element of matrix. Suppose we enter here simple elements. Elements are stored in this order because our loop is execute in this order only. Therefore, the first value is located at 0 0 location. The next one is at 0 1 location. Then 0 2 1 0 1 1 1 2. Like this, the whole matrix get initialized by using given elements. These locations are very important because whenever we handle matrix or we perform a different type of operations with matrix, then we have to always refer these locations. Therefore, these locations are important. It is a simple program to print and scan elements of matrix. Now, again, if I remove this part, then you can see here our matrix is 1 2 3 4 5 6 7 8 9. You know, the locations are very important. If I want this matrix in transpose form, what does mean by transpose? If I want to write transpose of this matrix 1 2 3 4 5 6 7 8 9, then the transpose of this matrix is, here the matrix is 1 2 3, and transpose of this matrix is 1 4 7, 2 5 8, and 3 6 9. What happened here? Rows and column get exchanged. Here 1 2 3 is the row, here 1 2 3 is the column. As I said, locations are very important. Therefore, if you watch it carefully, you can find that 0 0 value is stored under 0 0, but the value of 0 1 is stored under 1 0, 0 2 is stored under 2 0. Then the value of 1 0 is stored under 0 1. It means what? Here only there is an exchange between the values of I and j. Therefore, if you want to print a transpose of matrix, then you have to only change in these locations I and j. Okay. Let us combine this program with copy matrix. Here in next program, you have to first enter element of matrix and then create one another matrix, and in that matrix you have to store this element in transpose form. Therefore, here we change a heading of program and give heading transpose elements of matrix. Okay, here you have only again one more matrix. Suppose I take here T, it has the same size. Now here do the logic to transpose matrix. For the transpose of matrix, we have the same loop here, but only while transposing within the T of ij, call the value from x of ji, right? And now close the loop. Then here we have to print first element from X matrix and then print the element of transpose matrix. Let us see the output. Here is the output. Sorry, here I use copy paste, therefore you have to print here the element from T matrix, not X matrix. Here is the transpose order. All rows get exchanged to column and all columns get exchanged to rows. Got it? Here is the simple program. Now, if we want to print addition of matrix, if here you have a X matrix contain then you have a Y matrix which contain and here print the addition of matrix. Addition is performed in a simple way. X of 0 0 plus Y of 0 0 equal to Z of 0 0. Here X of 0 is 1, Y of 0 is 1, therefore the resultant matrix is 2. 2 plus 2, 4. Then there is 4. 4 plus 2, 6. 5 plus 1 again 6. 6 plus 2, 8. Then there is 7 plus 1, 8. 8 plus 1, 9. And 9 plus 1, 10. It is the addition of matrix. In this case, you have to scan first element of X matrix, then scan the element of Y matrix and give the logic of addition. It is a simple logic. Z of I equal to X of Z of ij equal to X of ij plus Y of ij, and you have to use a nested for loop for this operation. It is a simple program. You can perform this program easily by using addition of matrix. Okay, take this assignment and we tried this program. It is a simple program, addition of matrix. Now in the next program we have to print sum of rows and columns of matrix. That is, you have to print here the sum of first row is 1 plus 2 3, 3 plus 3 6. The sum of second row is 9, 9 plus 3 6, 15. Then there is 7 plus 8, 15 plus 9 is equal to 24. Sum of first row, sum of second row, sum of third row. Here also you have to print sum of columns. Therefore, the sum is calculated in this way: 1 plus 4, 5, 5 plus 7, 12. Then there is 15 and the 18. Okay. But while printing the output, you have to, or your output will be like this: row sum is equal to suppose 6. Then print the first column sum is equal to 15. Then again row sum equal to 15, column sum equal to 15. Sorry, column sum here is 12. First row, first column. Then second row, second column. Third row, third column. But if you want to print this pair 3 times, in this case what happens, whenever we create this program, here this loop get executed multiple times, but this loop only get executed 3 times. Therefore, if you want to print rows and columns, sum of 3 columns, 3 rows, then you have to write this statement in outer loop. How it get execute? Let us see. For this program, sum of rows and columns. You need here only a single matrix and take a variable for row sum is equal to 0 and C sum equal to 0, because how to calculate the sum? 1 plus 1 2, then 2 plus 1 3, like this. Write a mechanism for sum. Row sum equal to row sum plus x of ij, right? And C sum is equal to C sum plus x of column. That's why ji, right? And now here you have to print this sum in outer loop. Why? Because we want the sum of 3 row and 3 columns, and our loop is ready to print the to execute a 3 times outer loop. Therefore here print or here you can write a sum of row column. Okay, system. And whenever you print a row and sum of first row, first column, then you have to reset again row sum to 0 and column sum to 0 for calculating new sum for next row and next column. If you miss this two statement, then you will find that the previous sum is carry forward, and then the next row and next column is calculated by using the value of previous calculated sum. Therefore, you will not get the accurate result. Hence, reset here row sum and column sum is equal to 0. I put here values in matrix form. See the output. The first row is 6, second row is 2. Here, for separation, we have to use one more slashing. Sum of first row, first column, second row, second column, third row, third column. It is the sum of row and column. You can also modify this program by calculating the sum of all elements. For the sum of all elements, there is a simple logic. Only here, take a variable sum, which is again set to 0, and here calculate sum equal to sum plus. Here don't reset the sum variable because we want a final sum. And after termination of both loop, you have to write here sum of all elements. Here is the sum of all elements is 45. Okay. Now again, you have to again calculate the one more sum. If your matrix is 0 0 0 1 0 2 1 0 1 1 1 2 2 0 2 1 2 2, and if you have or you want to calculate the sum of diagonal sum of matrix, that is the first diagonal and second diagonal. The first diagonal is 0 0 1 1 2 2 and the second diagonal is 0 2 1 1 2 0. From the whole matrix you have to only add elements from these locations. If here you have a matrix elements, I put here simple values. In case of first diagonal, we have a value of 1, 2 and 3 only. That is 3 plus 2, 5 plus 1, 6. In case of second diagonal, 1 plus 2, 3 plus 1, 4. Then from the whole matrix, you have to only pick the values of which appear in a diagonal form. That means what you want to pick the value from these locations. In case of first diagonal, there are 0 0 1 1 and 2 2, and in case of second diagonal there is 0 2 1 1 2 0. If you watch it carefully, you will find that here the I is 0, j is 0, I is 1, j is 1, I is 2, j is 2. Okay, but in this case I is 0 1 2 and j is 2 1 0. Then how to pick these values? You can also here use a different loop. If whenever you scan the whole matrix, then all these locations are get initialized. Then use the simple loop and pick the value from this location, and in another loop pick the value from these locations. By using this logic, you can simply use a program to print sum of diagonal. Here the first diagonal sum is 6, the second diagonal sum is 4. Okay, let us see the program. Here change the variable and give this sum 1, that is diagonal sum 1, and this sum 2, diagonal sum 2. Okay, only you have to here use the separate loop. For in case of first diagonal, I equal to 0, j is also equal to 0, less than 3, I plus plus and j is plus plus. And here simply calculate the sum of first diagonal. This sum 1, in case of second diagonal, what to do? You can simply here I equal to 0, no, there is, yeah, I equal to 0, j equal to 2. I is less than 3, I plus plus and j minus minus. Then print the sum of first diagonal. Sum of second diagonal. Okay, let us see the output. In case of first diagonal, there is 1 plus 4 5 plus 1 6, and in case of second diagonal, there is 4 plus 3 7 plus 3 10. Here is the output. It exactly pick the value from first and second diagonal by using logic. Here you can also again calculate one more sum of upper and lower triangle. Then Here we simply put a matrix of 4 by 4. Locations are there is next one is, so here we have a 4 location, therefore 0 3. It is very important to write here again location because we have to know from which location we have a values. Okay, now in case of first diagonal you have this much element, that is 0 0 0 1 0 2 0 3. Here there is a first diagonal, and including this first diagonal and above values are the elements of upper triangle, and including this first diagonal and below this lower values are known as the values of lower triangle. Here pick the values within the upper triangle. There is, from the first, see the values of first diagonal, and from this locations pick all the above values as a elements of upper triangle. Therefore 1 2 3 4 2 1 1 3 4 and 2, right? Let us check 1 2 3 4 2 1 1 3 4 2, right? And in case of lower triangle there is again keep the value from first diagonal and put this in this location 1, then there is 3 2 1 2 3 1 2 1 2. Okay, here if you watch it carefully you will find that the value of I is 0 j is 0 0 1 0 2, but all in these locations we have a greater value of I, greater less or equal to value of I, because 0 0 0 1 2 2, here the value of I is either less or equal to j, because here I is less, and in these locations I is equal to j, and the opposite logic is applied to a lower triangle. Here the value of I is greater than j, or value of I is equal to j. Therefore it is very simple to pick these values from the whole matrix. You have to only check whether in which location the value of I is less than or equal to j. If this condition get true, then pick that values and add to a upper triangle. And in opposite condition, I is less than I is greater than equal to j, pick the value from that locations. And here if you watch it carefully you will find that our condition is true, that is I is less than or equal to j in case of only upper triangle elements, and the next condition I is greater than or equal to j in case of only lower triangle. Therefore it is a simple logic to check whether the value of I is greater or less than j. How to make how to make this program by using this logic, let us see. Here you have to write a nested loop. Before that, take a two variables, upper sum and lower sum. Therefore, here I assume up and low equal to 0. Now, we know that in case of upper triangle, I is less than or equal to j. If this condition is true, then only pick these values and add to a variable of upper sum. Don't write here else, there is no need to else. Simply write one more if. If the I is more than or equal to j, then put these values in lower triangle. Here is the close the inner loop and outer loop. And now print sum of upper and lower triangle. Okay. First check the upper triangle 1 plus 2 3 plus 3 6 7 8 9. Here is the right sum of upper triangle and lower triangle 3 4 5 6 7. Okay, you can also write a program to print elements of upper triangle and to print elements of lower triangle by using the same logic. You should make this program to clear your logic of matrix triangle sum. Here are the sum program we use to print sum of all elements, sum of row, sum of column and sum of upper and lower triangle. Now let us discuss the multiplication of matrix. In case of multiplication, you have to declare elements from two matrix. If the first matrix is 1 2 3, then multiply this matrix with next matrix. Take a simple values. It is the matrix of x and y matrix, and then how to calculate the sum. Here is the main logic. To form the element of resultant first element of resultant matrix, you have to calculate sum like this, multiplication like this, x of 0 0 into y of 0 0 plus only for a single element of resultant matrix, plus there is next element x of 0 1 multiply with y of 1 0 and x of 0 2 value multiply with y of 2 0. Let us pick the values. X of 0 0 into y of 0 0, that is what, 2, plus x of 0 2 into y of 2 0, that is 2 into 3 6, plus x of 0 2 into y of 2 0, that is 3, and here you will get the answer 11, which is the first element of resultant matrix. If you want to print here the second element of matrix, then you have to calculate this same row with next column. Again this same row with next column. Here the whole process is going on 27 times. In case of previous programs, we have to print or we have to scan elements of matrix, or we perform addition, sum of triangles, sum of rows column, but in that case your loop is execute only at 9 times. If you have a 3 by 3 matrix, then 9 times. You have a 4 by 4 matrix, then there is 16 times. That is multiple time processes perform. But here we have to process which perform at 27 times, because our matrix is of 3 by 3, therefore 27. One row is multiplied 3 times, therefore each element is multiplied 3 times, then 9 element is multiplied 27 times. Then how to pick values from this location, because here it is a 0 0, it is 0 0, no doubt, but it is 0 1 and here 1 0. Here is the 0 2 and 2 0. Therefore you need here one more variable to perform this logic. Simple logic, simple program, only you need a concentration to understand this logic. Watch it carefully. Here you have a 3 matrix X, there is Y and Z. You need one more variable K. But here what happened in this case, whenever you multiply the element from x of 0 0 into y of 0 0, then at every time you multiply the element from one location and then add multiplication to a previous value. Therefore you have to initialize the z is equal to 0, because within the program we have to store every multiplier value to a z as the first element of z matrix. Therefore initialize to 0, then again scan the matrix. If you want to assume here number of rows column and you want to ask user to enter number of rows column, then in that case you have to declare here maximum rows and column. But in that case you have to follow the one rule, that is the rows of first matrix is always equal to the column of second matrix, then only multiplication is possible, otherwise there is not possible to perform the multiplication. Again listen carefully. If you want to ask user to enter number of rows column, you want to give a choice to user, then here you have to take a maximum rows column. If you take here x of 50 y of x of 50 50 y of 50 50, and you ask user enter number of rows and enter number of column, in that case there is one rule, is that you have to enter same number of row, and if you want, if you put the, for example 10 value for a row, then you have to put a 10 value for a column of y matrix, because here the multiplication is performed row with column. Therefore if you have a number of rows 10, then you have of first matrix, then you have to write a number of element 10 in the column of second matrix, then only the multiplication is possible. Otherwise simple take a fixed value and take a all these values are same, there is no need to check anything else. Here the first scan the value of X matrix. Y, and now give the mechanism for multiplication. You need here one more loop. Then write z of ij plus we have to multiply one by one value from x of ik into y of kj, because in case of x we want row and in case of y we want column. Therefore set this k to x1 y. First close the inner loop, then outer, and then outer loop. Whenever this loop get false, then there is a answer is stored under a Z matrix. Therefore here print the resultant matrix. Okay, let us see the output. Let us check it. 1 into 4, 4 plus 2 into 4, 2 into 2, 4. That is 4. Previous sum is 4 plus 4, 8. And then 1 into 1, 1. Therefore 9. That's why here we write z of ij equal to z of ij plus x of ik into y of kj. Here you can see that initially I is 0, j is 0, k is 0. Therefore all these values are 0. Then k get plus plus. Therefore I is 0 but k is 1. And here also k is 1, j is 0. Therefore the next value is picked from 0, 1 and 1, 0. Because the k is 1 here, then k get plus plus, the k is 2 now, then the 0 2 multiply with 2 0. Therefore 0 2 multiply with 2 0. Like this your whole elements are get multiplied and you will get the result in Z matrix. Got it? Okay, now let us perform. You can perform this program sorting of matrix in three ways. The first way is row by sorting. In this case only rows are sort. For example, if the matrix is then what is the row wise sorting result? 1 3 5, then there is 4 7 9 and 1 3 4. The next is column wise sorting. Here the column wise sorting is 3 5 7, then it remains the same 3 4 4 and here 1 1 9. Okay, and the next type is all elements, sorting of all elements. In this case what will be the result? 1 1 3 3, then there is 4, 4, then there is 5, 7 and 9. Okay. If you want to perform either row wise or column wise sorting, then there is a simple logic. Compare this value with the two elements, that is, whenever you perform a program of sorting of single dimension array, in that case you apply the same logic. You have to compare this value with two other values or with all values of given array. That's like here also you have to compare this value to all these values contained in row. Therefore here also the single value compare the 3 times, therefore 9 values compare at 27 times. Then in case of row wise and column wise you need a 27 time process. And the logic is same, compare this value. If the value is greater, then swap these values. Therefore here we get result 1, 3, 5, because instead of 5 there is 1, here the 3, and here there is a value of 5. Therefore here only the location gets swapped and values get swapped according to locations. In case of column wise also you have to compare this value with the other values in given column. Here also you have to write a process at 27 times, but in case of all elements you have to compare a single value to all elements of matrix. That's why if you have a 3 by 3 matrix and the first one value is compared at 9 times, then 9 values compared at how many times? 81 times. Then in this case you have to write a for loop, because here we have a 3 loop 27 time, for 81 time we have a for loop. Okay, let us see the programs for sorting of matrix. For sorting of matrix you need only a single matrix. You have to print matrix element before sorting. Okay, then give the logic for sorting. For sorting here we need one more value temp for exchange the elements. For exchanging these all values we need one more value, like a simple sorting of array. Here temp is equal to first element from matrix, then within first location store the next value. But before this logic we have to write a condition. If x of ij is less than x of ik, compare these values. Here also the first is 0 0 0, then k plus plus, therefore 0 0 0 0 again compare with 0 1, then 0 2, then whenever k get false then j get plus plus, then 0 1 value compare with again 0 0 0, then 1 0, then 1 2, like this all logic get works. Then the next step is temp is equal to x of I k. Okay, close your bracket appropriately, and now print after sorting or sorted element. what happened here? We don't give a slash n extra, therefore there is no matrix form. If you want to output in a matrix form, then you have to write here printf slash n. Okay, 4 5 4 3. It is there is some mistake. Let us check it. X of ij compared with ik, temp equal to x of ij equal to ik. Oh, here is ik equal to temp. Okay, 12 56 34. The output is 12 34 56. It is a sorting order. 87 56 11, 11 56 87, and 45 87 65, 45 65 87. It is a right mechanism to print the row wise sorting of matrix. If you want a column wise, then here put a k value at the row level. Here we put a k value at the column level. If you want to column wise only, change this logic and here write a kj. Then you will get the sorting order of columns. But if you want to print sorting of all elements, then you need here one more variable because the process is going on at 81 times. Therefore, here add one more loop. Then k h, right? Because one element is get compared with all elements. And now here print sorting of all elements. We have one error. Here close one more bracket. Okay, 11 22 23 34 37 45 65 60 78 87, right? It is a sorting of all element of matrix. You can also write this program or any of this program in function also. If you want to put this program by using user defined function, then there is a simple way. You have to put all this logic to a sorting of sort mat function and call here the function. We have used function part in case of array also. Like this, you can use a function in case of matrix. If you want to perform here the function, then simply write here function. The function is return type is void. The name of function is sortmat. Pass here a single matrix. But in function, you need only give a number of columns. Then put all this logic here. But for function, you have to declare here I, j and h and temp also. Okay. Then within main there is no need to declare k and h and temp because all these variables are required only a function part. Then here you need only to calculate to call a function. The name of your function is sortmat and the value is x matrix. Like this you can also change this program by using function. What happened? Yeah, here also declare one more variable k. Okay, here is the output by using function. You can also take a function for get max and show mat. It is a user defined function to perform sorting of all elements of matrix. Okay, in next lecture we have to see what is meant by structure. Thank you.